Hello, Keith Rucker here at VintageMachinery.org. Guys, today we are back working on the steam Stoker engine, and kind of along the lines of what we've been working on here recently is getting these connecting rods for the crossheads connected to the crankshaft. The next big step on that is we got these bearings that go on the back of the connecting rod. This is what fits up over the crankshaft. These are, I believe, going to have to be bored out to get to the correct size over there. I need to get some measurements on them, get an idea of exactly where we are, and just kind of get these things cleaned up and ready to go. So I don't know exactly what the game plan is going to be, but right now what I'm thinking is that we will probably, depending on how much has got to come out of these, but probably set this up over on the milling machine, the vertical mill, with a boring head and bore it out. It seems like I remember that I got some measurements on these before, and there's a good bit of metal that needs to come out of these, but I need to confirm that. I may not be remembering it exactly right. We'll find out here in just a little bit. So let me kind of show you how this setup works. This got this strap back here with two bearing halves that fit up onto the connecting rod. Let me show you how that mounts together, and then we'll get started getting some measurements and coming up with a more definitive plan on how we're going to resolve all these problems. Let's get in here and take a look at it. So I think the first thing I want to do here is get these separated. I've got a little dead blow hammer here. I also got a brass punch. Got to get it moving first. You should slide apart, but they're a little bit tight. Hopefully when we get them cleaned up, they'll slide better. All right, it's moving a little bit now. Let me see if I can. I will note that I've got witness marks on all these so that I can make sure they go back onto the same strap and in the same order, same position, and everything like that. So I did do that before we started taking these apart. Here we go. So one interesting thing to note is that I can tell that these surfaces right here have been milled, so these have come out and they've actually reduced the size. Basically they tightened them up to where they came in contact with one another. They had to mill some material out there to open that gap back up. So these have some wear in them, but there's plenty of meat left in them. These are not in bad shape at all, so I don't see a need to have to make new ones or anything like that. All right, I got those done. I'm going to take all this stuff over to the wire wheel, get it cleaned up real good, and then we'll see about getting some measurements. I've been doing a little bit of detective work, inspecting here, trying to figure out on these bearings which direction I need to go. And I've shared with you guys before, I've got a bunch of information on the Stoker engine that came when I got it. It came out of one of the railroads and their archives. They had a lot of the original blueprints for the parts of this, which has been very helpful. They also have some of the specs in here, you know, what is in tolerance, what is out of tolerance, etc. on these Stoker engines. Again, very helpful information. In this book, you got the connecting rod and wrist pin brasses, and it talks about here the limits of wear for these different parts. Now, we know that the crankshaft is 2 3/4 in diameter. That's what it was ground to. That's exactly what it measures over there. And that's, again, we made it back to spec. So we are back on spec on that diameter. Here's the issue that I've got. It says on here the limit of wear that we have on that 2 3/4 is 2 in 25/30 seconds. So basically what this is saying is that 25/30 seconds is 1/32 of an inch larger than 2 3/4. For comparison, a 32nd of an inch is 0.09375, so just a little less than 100 thousandths in diameter. So as that gets to a 32nd, undersized or oversized rather, that bore, it is now past the limit of wear, and basically when it reaches the limit of wear, it says you need to get some new bushings and replace them and bore them to the size that they need to be to match your crankshaft. All right, so I don't have, this book is full of blueprints and stuff of the parts I do, but it does not have the blueprint for these brasses. It does not have the blueprint for the strap and some of the other parts related to that. Why, I don't know. It's got the blueprint for this brass down here in this end, but it doesn't have all the blueprints. It is what it is. So based on the information here, and even though I didn't have the blueprints, I was able to do some extrapolating to kind of come up with what some measurements need to be in tolerance. This little drawing that I made, this little U-shaped piece represents the strap, okay? Now I measured this distance here with a set of calipers on both straps to come up with that distance. I also measured the brasses and the distance between here. These are milled flats, which kind of correspond to it over there. Little surprised, it was a 64th under 3 3/4, but they consistently measured out at 3 47/64, or 3.744 inches, within a thou or two of that number. So just for the purpose of my calculations, I'm going with that being that distance, which is also the diameter on this back side back here. And then I took that and calculated the radius, which is 1.872. I then calculated the radius of the bore based on the minimum and the maximum. The minimum, the smallest size to be right on size is 1.375 would be the radius. Again, the diameter would be twice that. And the maximum, basically at limit, is 1.391. So based on those two radiuses, I was able to calculate the thickness of this brass in here. It basically needs to be a maximum of 0.497 inches thick to a minimum of 0.481, okay? So now, next step is to measure the actual thickness of the brasses. Now that was a little more challenging because I didn't really have much to reach in there and measure with. I ended up just using a caliper here. There is one caveat to this method, and because we're measuring this anvil on the inside is on an inside radius, you know, it's actually making contact on either side, so there's a gap in there. And if I wanted to, I could calculate what that gap would be, but the point is that it's not an absolute measurement. They actually make micrometers that have a ball anvil on them that are for this purpose. I don't have one to get a proper measurement, but just note that my measurements that I'm making are going to be a little bit larger than the actual because we're contacting on the two corners and we're not contacting in the center. But I did go in there and measure them, and one of them measured 0.489, the other one measured 0.482. My minimum is 0.481, so again, the number's going to be smaller than this, and boom, we're really right on the minimum on both of those. So these bearings have really, according to the manual, according to the specifications that were given, they're either right at or possibly have even surpassed their tolerance for the wear, so the limit of wear. So bottom line, as much as I hate to do it, I think we're going to have to make a new set of brasses for this thing. Now, I did come in here and measure the diameter just across this measurement here. That is beyond the wear limit. I don't remember what the number was, but I did measure that. It is beyond the wear limit, so there's a little bit of play up and down. I can take these bearings and put them on the crankshaft, and they appear to fit tightly in there. However, I can't really see the inside to make sure it's making contact all the way in, but I think these are already oversized by just a little bit. So boring them out isn't really going to be an option. I mean, yes, I could crunch them up together tighter, get into some more material on the sides, but I don't even think I would hit on the ends. By the time I got up to the ends, it wouldn't even be touching. And if I did that, I'm still decreasing the thickness of these bearings, and we're already at the limit of wear. Now, why is that important? Particularly on this back side, as your wear gets thinner and thinner, the center of this piston is moving backwards and backwards, and that's affecting the stroke of the piston. It's moving backwards as well. So this is important that we have this thickness be correct back here on the back. This side up here is adjustable, so I mean, we could shim it up to make a difference. And I mean, I guess I could put a shim back here in the back to kind of move it out, but I just don't think that's the right approach to solving this problem. Again, as much as I hate to do it, I think we're going to need to make a new set of brasses. So what's all involved in making a new set of brasses? I mean, there's a couple of routes that we could go. I could get a solid piece of bearing bronze and just machine these out. That's definitely an option. The other option is I make a pattern. I have new pieces cast and then machine those out. If you look here, you can kind of tell this had a cord in it back here. This was cored out, and this was originally a rough casting that they machined. I'm gonna probably price and see how much it would cost to buy some bearing bronze, just some blank bronze to cast these out of. But I mean, not to cast them out of, but machine them out of. But you got to remember that from a weight standpoint, probably 3/4, if not more, of the material is going to end up in the scrap bin. And bronze rather is expensive. Bearing bronze is expensive. Just to buy the material for this thing, I'm guessing is going to be $400 or $500, maybe even more than that. I just going to have to figure it out. If I get them cast, the weight of the casting is going to be considerably less, and I've got some bearing bronze that can be melted down that I've already purchased at basically scrap value prices that I know is bearing bronze. It came out of bearings, so my foundry guys got some material that we could use to cast some new ones out of. And from a standpoint of just time and machining and all that, it'd be a lot easier to machine the castings than it will be machining solid stock, just because, again, the vast majority of that solid stock is going to disappear. If we have a casting, a bunch of it's going to already be gone. So I'm going to price it out. From a time standpoint, I could probably do it faster if I just machined it out of a piece of solid. Just from the standpoint, I'm going to have to design these, draw them up in CAD. I'm going to have to design the patterns in CAD. I'm going to have to get patterns 3D printed, send them to the foundry, get them cast, get them back. I mean, this is going to really slow me down if I go that route. Anyway, I got to figure that out. I'm gonna as I start looking at pricing and whatever, I'll figure out what I'm going to do and how I'm going to go about it. But bottom line is we got to make new brasses here. Well, guys, that honestly was not what I anticipated this video being. I was really just thinking that we were going to get in here and be able to bore those out and move on with this project. But yeah, surprises come along. I need to probably check out the brasses and the eccentrics as well that go in here. That's a little bit later down the process, but I'm kind of concerned that those might be worn past their wear limit as well, and we may have to replace those. And if so, if I got to do castings, I might go ahead and get those done kind of at the same time. I'll probably go ahead and get ahead of myself and take a look at that before we get too deep into this whole process, just from a time management standpoint. You know, there's so many things that have to be looked at on this engine. If I had seen this 6 months ago, we'd have the casting sitting here ready to roll, and this wouldn't be an issue, but this is gonna slow me down, at least back here. The good news is there's other stuff on the engine that's gotta be done that I can kind of skip ahead and start working on some of the other things. But in my mind, the order of process that I was planning on going, this is gonna affect that. But hey, we'll deal with it. We'll get it done. This isn't an end of the world situation. It's just wasn't the plan, which is the reality of life in general, I guess. I'm getting philosophical now. All right, guys, with that, that's gonna be a wrap. As always, thanks so much for watching. Please do subscribe if you haven't already. Those thumbs up, those comments are always greatly appreciated. Hit that bell icon up there to get notifications when new videos are posted. And as always, a big, huge thank you to those who support the site financially through Patreon, PayPal, and YouTube memberships. All those are really great ways to help out my channel, as well as any other creator out there that you follow and get value from. So please consider that if you haven't already. And with that, we're going to sign off. We'll catch you guys on the next video. Again, as always, thanks for watching.